we have this card, and this card is going to be super helpful for section 5.2 homework. A very specific section having to do with not just every type of growth and decay, but what did I put in here? What type of growth and decay? And that adjective is making this very specific. That adjective, exponential growth and decay, is making it very specific. As we get back to the example I had you guys playing with at the beginning of class, let me show you first of all, though, where homework starts, okay? Homework. Where does homework start? This first section, I think you guys have 1 and 5 and 8. What are the directions up here? Oh, so wait a minute. If you're just supposed to start with solving, no word problems, no graphs, no slope fields, what are you going to do in every single one of these problems as you go to start? Well, this one's the easiest one. What are you going to do? Multiply the dx, and then, if possible, you're going to go ahead and take the integral on both sides, right? Is it going to be possible to take the integral right away? Yeah. Why is number 5 and number 8, why do they look a little different? Okay, so well, there are y's and x's, but also there's a y prime. How are we going to rewrite y prime in both? And then what are we going to do with the dx? Move it, but as we move the dx in this one, who can't stay? So we're going to also move the y and then take the integral of both sides. This one, same thing, dy dx, move the dx. Whose doesn't belong though this time?
1 plus y.
The 1 plus y. Do you see that it's an entire group? So we're going to divide the 1 plus y to the other side and then take the integral of both sides. Pause. Did we do an example like that kind of yesterday? I think so. It wasn't this one. It was the one right before it. Aha! So if you want to look more like homework, you could go to this example right now and be like, hey, y prime, okay, make it dy dx, okay, make the dx, okay, recognize he doesn't belong, divide him over, and then integrate. When you integrate, could y be kind of stuck inside his own antiderivative? Yeah. So theoretically, you could, if you're checking some of those odds, you could check CalcAB and see if your initial antiderivatives were accurate. If you get stuck trying to get y by itself, you can bring that to class tomorrow. But we are going to, because we're going to have stuff on this side sometimes now too, y might be stuck in his own antiderivative, so you have to do some pre-cal, maybe like addition or subtraction or ease or squaring or whatnot to get y by itself. So do the best you can, and we'll bring it in tomorrow and see where the simplifying or where the getting y by itself got hard, if it gets hard. But hold on. Okay, wait a minute. We're looking at the graph, so hold on. Where does homework go next? Whoop. What's number 11? Right? Right? The differential equation? No. They always give it to me. Why are we writing the differential? Oh, there are words. Oh, there are words. And I can't just do all your homework problems, but I can do number 12. You guys can either just ponder it or you can write it down and then think about it later. Number 12 says the rate of change of p. Guess what? That's p prime. With respect to t, okay, p prime of t, sure, is proportional to, well, I could name this dp dt if that helps. Remember how we can make the y prime dy dx. So the rate of change of p with respect to t is proportional to. If they don't tell us what type of proportionality, what do we assume? What type of proportionality? Direct or inverse? So, and direct proportionality, we talked about that yesterday, is k times what?
25 minutes.
What are you going to do? We already wrote it, haha, but now we have to solve. How do we solve it? Like we did those ones. Move the dt up, bloop, bloop, bloop. Does anybody not belong if I move the dt up?
K.
But what is k?
Constant.
K is just a constant. Do I mind constants wherever they? Nah, so I'm fine. I can integrate, and when I integrate, I get p of t is equal to,
You have to use it.
25 kt minus kt squared over 2. What? How did I do that?
Maths.
Isn't 25k just a constant? What's the integral of any constant? The constant times the variable. So 25k was just a constant times the variable t. minus, how do I integrate KT? KT squared over 2. Proceed. Wait a minute, can I make this particular, or am I done with the general solution?
It's just a general.
Because what don't they give me? They don't give me any clues. Now, hold on, wait a minute. In your notes at the beginning of class, do you have some clues? How many clues? Which is good, because how many unknowns do you have?
I don't know that.
How many unknowns do you have?
Well, like 3.
Y is okay, he's the Y. T is okay, he's the X. E is okay, it's a number. Who do I need to find?
KC.
C and K.
Oh.
Ah, 2 clues, 2 unknowns. I think that's like algebra or something. Anyway, that's the next part of homework. Oh my goodness, where does homework go next? You guys see the next section? Slope fields. Slope fields. Now hold on, wait a minute. Sketch 2 approximate f. That's following the flow. That's easy. Use integration to find. Oh, I have to move the dx and take an integral? Okay. And then it says, use a graphing utility to graph the solution. Once you solve the differential equation, once you plug in your and get a plus c, that's an actual equation you can plug into your calculator. Just plug it in to see if it follows the flow the way you thought it did. All that is, you don't have to get a slope field on your calculator. Some people would think they need some special slope field program. This is just saying once you solve it, graph it, and see if it follows the flow the way you thought it did. Or if it has the same shape. We're still solving. Oh, what do you see right here?
The problem we're just about to do.
Ooh, that looks nice. Because it gives us this general y equals c e to the kt, and it says, hey, figure out if it, okay. So are we doing things that look like homework? Yes. I think we missed one up here, but it was one of those clue-ish ones. Oh, hey, but this clue-ish one, this time, okay, the rate of change of n, so dn dt is proportional to kn, blah, 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 blah. Am I going to actually be solving this one? And plugging in? Yeah. Because they gave me 2 clues, just like the graphs give me 2 clues. I'm going to be plugging in, and then I'm going to, okay. This one, there's plugging and chugging. We'll be able to find the C and the K. So let's practice finding C and K with these 2 points in a graph, but realize it could also give us 2 points in like a sentence, a paragraph. Let's figure out how to use the 2 points in a graph, and they'll be similar to how to use the 2 points when they're given to us in words. So you guys should have plugged in, not red, blue. You should have plugged in both your clues, right? When you plugged in both your clues, we have T's and Y's, like X's and Y's. So when y is 4, t was equal to 0. And when y was 1/2, t was equal to 5. Now, how did you guys know this was decay?
The curve is downward.
Okay, so the function, the solution, the flow is decreasing. That helps. And my y values have gone down. The amount has gone down, right? I now have what? 1/8 what I used to? Anyway, 1/8 isn't super special. When you guys want to go plug and chug and solve this guy out, I'm going to use green because this is pre-cal. This is review stuff. Anything to the 0 power is 1, which means C is equal to 4. Because that's just going to all go to 1. C times 1 is 4, so C is 4. So what can I do when I come over here and I need to solve? Plug in 4. So 4 is equal to e to the 5k equals 1/2. I can divide by 4, I get 1/8. Aha, do you remember your pre-cal? How do we get rid of e?
Ln.
When I ln it, I end up with 5k is equal to ln of 1/8. So k is equal to 1/5 ln of 1/8. Now, we could make the 1/5 a power. Do you know how that, well, I'm pretty sure it's going to make everything gross. Now, I was actually, though, Carl, I was going to show something with that 1/8. Can't we make 1/8 2 to the negative 3? Oh.
And a scoop.
Do you see my cool 1/8 became 2 to the negative 3? Are you tracking? That's kind of tricky.
But like, what ln of 2?
We don't know, but can't we bring the negative 3 in front?
Yeah.
We can't k equal negative 3/5 ln of 2?
Sure.
And you can just pop back up and go.
ln of 2 is one of those really important guys to doubling in half-life. I bet Mrs. Meow would have it memorized to so many decimal places, but I don't. That's exactly why I'm showing this though, right? The AP can show it this way. Okay.
Whoa.
Wait a minute, what are we supposed to be solving for?
Particular.
So do I need to take all my info and I need to plug it in?
Yeah. Nice.
Isn't that easy?
Now, what does this mean in context of the problem? If I was to go making this about something like, I don't know, some radioactive substance that is decaying over, what could 5 be? Thousands of years? Hundreds of years? Anyway, 4 is the initial amount. 4 is where it started. Same thing as the intercept for any exponential growth and decay. Remember, we're in a special section, a special type of growth and decay, only exponential. So 4 is the initial. Oh, wait a minute. Isn't that what we wrote down in our card? Didn't our card say that that little constant in front, the C, is the initial? And I showed you in the math, the integration as to where that C came from, kind of coming back to like 3 cal properties of addition of exponents, blah, blah, blah. But in context, yeah, that C is always going to be the initial amount for exponential growth. Remember, special type of growth, not all growth. Not like integration is net change, I don't know, the bananas are changing. Specifically exponential growth and decay. But this guy will always be the initial and exponential growth and decay, and then this little K guy shows me the rate of proportionality. So what are you going to do when you get in your homework to this guy that has words, but really it just gives you 2 points?
Yes.
Plug him in, plug him in. Wait a minute, don't you guys already know that 250 can be the initial, the C? Maybe we could save ourselves some time. But plug this guy in, get your C, get your K. When you get your C and get your K, don't you have a nice little equation that you can now use? There it is. That you can now use?
Yeah.
So what does the homework ask you to do in this problem after you find the nice little equation that you can use?
Looking for?
Use it. Exactly.
Just
And then after that, you have the graphs that we just reviewed how to do. And oh my goodness, we're already like, I don't know, 1/2, 1/3, 1 something through homework. Where's the next stuff? Ooh, we have words coming. But guys, what happens before the words?
Oh, just half-life. Oh.
Oh, radioactive decay. All right, so before we get into the word problems, and I have some over here to the side, I'm trying to make this very applicable to your homework. A lot of these examples are kind of from an old textbook that I used to use. So let's go ahead and get this table in, and let's talk about the table. I'm not going to solve your homework problem, but I'm basically giving you the information that you need. So, let's go ahead and skip down to the 30s. I mean, we could start with the 29, 30, 31. Wait, who are these guys? Who is 226RA, or 14C, or 239PU?
NFC is carbon.
Hey! Carbon 14? Carbon 14 dating? What? Who's this guy? I thought it was radon, but that was off the top of my head, and I haven't seen a periodic table in ages.
It's on my calculator. Let's see.
There you go. PU, is that polonium?
Oh dear, they don't have a label.
No, that's AU.
RN is radon. Okay,
Although I was at a trivia night the other night, and they have this category thing where it's like, hey, what do all of these have in common? And all the answers, the first 2 letters were elements. And I was like, that's sneaky. I didn't know all the answers, so I didn't catch it anyway. But that was very sneaky. PU and RA. What's PU? What's RA? Anyway, doesn't really matter.
Plutonium.
So does it really matter who the isotope is? No, not at all. None whatsoever. What does matter is that these have radioactive, or these are radioactive decay. And guess what radioactive decay patterns after?
Oh.
Exponential decay. Wait a minute, exponential decay has a negative. I know, but even if you don't put the negative, isn't the K going to end up being negative?
Yes.
So technically it's not a huge deal if you put it or not, because you're going to end up with the proper amount anyway. However, let's just go ahead and take, well, you guys have 33.
36. Let's start hard.
We could, or we could do something that's kind of similar and do number 29. Number 21, or 29, sorry. Number 29 gives us the half-life in years and the initial. Hold on, wait a minute. If we know that radioactive decay all is following exponential decay, what can I do with this 20? Oh, so right away, I already know for number 29 that I can go ahead and throw in that 20 as my initial amount. Now, what's going to happen to that amount as time passes? Oh, it's going down, and not just is it going down, but it's going down such that it's going to be half as much as it used to be when time is 1599. Now, I used this idea in that pretend forever card that we're not making a forever card, but it's pretty important. I use this idea of the ratio. If I'm thinking of doubling, then the ratio is going to be 2, or if I'm thinking of half-life, the ratio is going to be a half. The nice thing of thinking of ratios is that I can use this no matter what. Even if they don't tell me what I started with, I can know, okay, well, it's half of what it was, so this is half, and I can set it equal to that E guy. But Adam was also saying something that was super valid. Adam was like, hey, it's going to be 10. How did he know it was going to be 10 after 1,599 years? Because what is half of what it was to begin with? 10. So one way is to go ahead and set my y equal to 10 and say 10 is equal to 20. You could have done that. Oh, sorry, when t is 1599, not just t. There are a couple different ways of doing it. You could plug in 1599 and be like, you became 10, but then guess what? When you divide, you get my ratio of the half. So either way, it works. And all we have to do to finish this problem, guys, is solve for, well, maybe not all we have to do. What's going to happen when we divide by a negative is that ln is going to become a negative. That negative could become a power, which means I could have ln of 2. All over 1599, and that's what we saw yesterday in that doubling or half-life can all come back to the same constant of ln of 2 over the amount of time it takes to double or the amount it takes to be half. So just remember, for decay, that's going to go inside a negative exponent, as opposed to with growth, that's going to go inside a positive exponent. But wait a minute, that's not actually what they were asking for. I mean, we needed it. What are they actually asking us to do in order to fill in the rest of the table, guys? Find the value. So I needed my nifty equation of my initial e to the negative ln of 2 over 1599. ln is only of 2 to 1599 is separate. Times t. But guys, at this point, hold on. Don't you just have to plug in t is equal to 1,000? Or t is equal to 10,000? Which problems would be a little more interesting than number 29 or 33?
31, 32, 30.
Why are all these ones? Why would all those ones have been more interesting?
It's not initial.
They didn't give you initial, so you would have to plug in 2 clues to solve for your C and solve for your K. Kind of like the graph, but it wouldn't be as nice as having like the whole power go to 0.
That's where you were studying.
So that's why I gave you 33. Yeah. Because we don't want to go too deep, and once again, the AP doesn't necessarily require us to get too crazy into exponential growth and decay, because you're like, okay, that's a great application, but a lot of people just memorize stuff like this ln of 2 over the half-life over the doubling, and they don't want you to just be like spitting out stuff that you memorized. Well, okay, derivative rules and integration rules, yes, but not when it comes to applications. Okay, sorry, I'm trying to keep this very applicable to homework. What happens after the chart?
We get into
More radioactive. Carbon-14, but kind of similar to this, right? We have stuff that's decaying. Compound interest. Whoop. Compound interest. That's something we learned in like Algebra 2 and breakout. Why is it here? PERT.
Oh, I got it.
What is PERT?
P equals
ERT. No. Wait, but there's a whole formula.
No, it's the formula. You're thinking of the other interest.
Principal E to the rate times
You're thinking of the compounded so many times a year. This one's continuously compounded. Yeah, 1 plus r over n raised to the nt. Something like that. I think it's p times all that too. So wait a minute. Oh my goodness. Continuously compounded interest is exponential growth, which is why our personal finance class here in this campus is all about like, hey, how to save now for the future using or benefiting from compound interest. Although our financial situation is a bit trickier than when that program was first made.
But if you get in now and the stock market goes, you're going to make big cash.
Yes.
That's what Hampton's doing. He's going to stock market really low.
He's not doing penny stocks though, is he? Not that low.
No, but
penny stocks. That has to like consume your entire life. But he's trying to, But the stock market's always a gamble. I don't know. Personal finance, it's not saying to go invest in the stock market per se. It's trying to be a bit more stable. But the idea is start investing now, or as soon as you start making money, start investing or start saving as soon as possible, because it's just trying to show you that for this interest to really pay off and pay off big, the earlier you start is what's important, not the amount that you put in. So don't wait until you have tons of money to start saving. Be like, no, just save a little bit now. And keep on saving a little bit. And that actually is a biblical principle too, as far as like tithing and holding back and being wise with our money, etc. Guys, do you see word problems are coming? Who's that guy? Okay, so I want you guys to look at the directions of this word problem, and I want you to compare it to what we're about to do, because we still have some time, and remember, we're trying to do as many practice problems as possible so that you are exposed to the directions, the wording, the vocab that's to come. That's what we did with slope fields. We had things like solutions and differential equations and particular versus general. And hopefully understanding that wording helped as you guys tried to get in that packet for me. Hopefully got in that packet. That's a small stack for me this morning. But number 56, what are some of the words that you see? Yes, it's bacteria, but remember, that's just the specific case. Look at the words. Okay, it says exponential growth, which means we're allowed to use CE to the KT, or negative, no, positive. Why positive?
Growing.
Those bacteria are growing. Wash those hands. Okay, what else?
It gives us certain.
We know certain parameters, but we don't know
Bacteria in the culture after 2 hours.
Ooh.
That's a little point.
Yeah, and we have 2 of them, right?
Yeah.
But are either of them the initial?
No.
That's what we have to find.
Bummer.
dude.
Bummer. But wait, if we have 2 points and we have 2 unknowns, C's and K's, should there be a way for us to solve it? System of equations. I wonder what a system of equations would look like. Before we go tackling the word problem, can I just show you an example of the system of equations with exponential growth? What if, pre-cal review, green pen, what if you have something like, I don't know, it's 5 after 3 hours, and it's 17 after 4 hours. That's kind of like what you guys are going to have to do to start off that problem. Plug in the T, plug in the Y, plug in how long, and plug in how many. So what you going to do? Elimination, I hope not.
I'm going to solve.
Sub? Okay, so substitution, what are we going to solve for?
C.
Yeah, C is a lot easier, right? So 5 over e to the 3k. Now what?
Plug it in.
That's what substitution's all about, yeah? Solve for one, plug into the other. We end up with 17 is equal to 5 over e to the 3k times e to the, do you see why we're doing the pre-cal?
Yeah.
Do you know how to get k off?
Can you? Is this illegal? If you cross out the e's and you get e to the k. Yeah.
Well, no. What he said isn't totally wrong, but the way he said it is wrong. You say, can you cross out the e's and put e to the k? Better way of saying that. I can't cross out the e's.
You can just reduce.
But I can reduce them because I have division of like bases, right? So wait a minute. What happens when I divide like bases? The power subtracts. Right? We reviewed the other day when you were multiplying like bases, that's addition, or I should say when you have addition, that's multiplying like bases. And now we're reminding ourselves if you're dividing, you subtract. So was Kyle right that it was e to the k? Yes, just not the crossing out part. Well, no, the reason why we started laughing is because literally, Kyle, I have people that just would have gotten rid of the e's. And I'm like, that's what I thought. That's what it sounded like. But then he said e to the k, and I was like, nah, he's got it. He's just saying it weird. So reduce. Reduce. Now wait a minute, I'm not done yet. Am I?
Yeah.
17 over 5 is equal to e to the k. So what's k equal to? Am I done?
No.
Not for the problem that we were doing.
No.
But I have 1, and once I have 1, what was that snazzy pre-cal term? Back substitute? Go back and plug it in. Just because. Makes it snazzy. And it might send you back in time to all those systems of equations where you would always solve for one and go back and find the other. Anyway, maybe it doesn't. C is equal to 5 over e to the do you know how to find it? Okay, this is why we're doing pre-cal review, yeah? Because this would not be a calculator problem. I mean, nice, right? That was a long answer. But how do you simplify? You can. How? If Kyle starts saying cross out again, I'm going to get mad.
Reduce.
Oh, wait.
But,
Close.
but how? How do I get the e and the ln next to each other? Because I can only simplify. Right?
It's a lot.
Now I can reduce the e to the ln because as soon as I put the 3 up here and he's gone, now I have e to the ln. They're inverses of each other, so I can go ahead and say c is equal to 5 over 17 over 5 cubed? Otherwise known as 5 to the 4th over 17 cubed. What?
The trumpet. Jesus is coming, baby. Jesus is coming back.
17 cubed over 5 cubed, the 5 cubed flips up, or the 5 over 1 is multiplied by the 5 cubed over 17 cubed. Dun, 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 dun. Okay, do we have the K? Yes. Do we have the C? Yes. Can we plug them both in and get our original equation to use in whatever way they want? Yes. Are we okay?
Yes, we can.
Yes. All right, let's go play with words then. Okay. No. This pre-cal is what you're going to need to use on that problem in homework. So I don't know. But the numbers are different. Anybody else want a picture? Good idea. Yeah. You guys saw where to use it, right? That whole, like, what's the initial? And they give us 2 clues. You're going to have to plug them both in. Boop, boop, and then play. Get C, get K. Put them both in the original equation. And then you can do whatever they ask you to. Like, write an equation. Use the equation to plug in 8. Ooh, wait a minute. What happens if they... let's get to the word problems. I'm just, like, giving you how to do your homework problems. Okay. Yes. Yes, you can use a calculator. Now you can. That whole e to the ln, I just wanted to make sure that you knew what to do without a calculator. Question, is this one as hard or easier than the one that we just saw?
Easier.
Because, what did they give us? Perfect. Now, when they say find an initial value problem, this was more wording in another book, but it's just kind of trying to remind you of why or how we're doing this. Exponential growth. What do we know about exponential growth? The rate is directly proportional to the amount, but but because this is so special, such a special type of growth, we can kind of just be like, oh, but we know what happens. We know that it goes here. Dun, 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 dun. And initial value problem, we have the rate, we have the differential equation, we're kind of like, ooh, we know what's going to happen. We can kind of just jump here without taking an integral, which is why the AP says, yeah, we're not giving you these ones. But we can jump here because we know what's going to happen. But the initial value problem says, what's the differential equation? Got 'em. And what's the clue? And the clue is exactly what you guys said. It's the nice, I know the initial 1,000. That's part A. That's just the initial value problem. And you guys have actually seen an initial value problem on a test. It was a differential equation. It was a clue. You had to plug and chug after taking the integral. I think it was chapter 4A, the one you guys just recently did corrections on. But that's like the setup. The setup is differential equation, got it, exponential growth. Okay, in parentheses, we know. And the initial. But then when we go to actually start solving to find a formula, it's like, oh, I don't have to integrate. Because I know it's going to be y equals 1,000 e to the kt. Uh-oh. What's wrong though? I'm supposed to find a formula, and I plugged in a C because they gave me the really nice clue. Oh, it was 10,000 on
Well,
this
it's
0.
2% per hour.
Oh, what does that mean?
It's a rate, a constant. So like one.
They don't usually give it to you, but this one did. Yeah, so we can plug in the K. It's the constant of proportionality, the rate. So we can actually go even farther. Farther is actual distance. Further is going more into it.
There's one you do every day.
Farther versus further. Then versus than. Affect versus effect. So many words to keep straight in English. We have our initial value problem was, okay, the setup, we have our differential equation, exponential growth, we have our clue. Oh, that should have been blue. What was I thinking? I'm sorry. Okay, and then, boop, we can use all of those clues to get ourselves an original equation without taking an integral. Once again, why the AP doesn't like using these guys, because they want you to actually integrate to go back from a differential equation. But then part C says, how long does it take? How long? Come on. Where are we finding what variable?
Time.
T.
How long does it take for the initial to double?
So just set it equal.
Set what equal?
The formula.
Well, T I don't know. This I do know.
And you said it equal to 20,000.
Oh, because this tells me how many I have currently, right? And I want how many I have currently to be double what I had. Or we could be super snazzy and just be like, oh, 2 is equal to that e to the kt thing. Remember, the ratio will be 2, even if I don't know how many I started with or how much I was ending with. Doubling says, oh, that ratio is 2.
I'm guessing ln.
ln? Oh, yeah, that ln of 2, he's super important all the time. And then divide by the rate. T is equal to ln of 2 all over k, which is another special relationship we saw yesterday with doubling.
What's the
Ln of e, remember ln undes e?
No.
Oh, you're trying to think of like a relationship?
No, how do we like simplify the 0.1 you multiply by 10?
Yeah, you could make that 2 100ths, which would be 1/50ths, and then multiplying that would be the same thing as 50 ln of 2. If you want to write it all pretty.
Would this be a multiple choice question?
Well, okay. Remember the AP doesn't love asking doubling and half-life just because it is so formulaic. People can memorize. Basically. No, basically, yeah, because calculus isn't really required. It's more of like a Ken thing of just memorize. It's ln of 2 over k or ln of 2 over time to double or half-life. But Adam is trying just to be ready for any answer with an ln that they could rewrite.
And we could even do a power.
We're not going to raise 2 to the 50th. They'll stop there. They'll stop there. But you guys could plug it in. You could get a decimal, right? No big deal. We're good on not having to plug into our calculator and actually practice doing ln. Careful of 2. That ln is only of 2, right? Not of anything else. Okay. What's going on next? Woo! Doesn't this look kind of similar to that problem I just skipped in your homework question?
Yes.
How long? What are you finding? When bacteria is... Oh, not bacteria. Yeah, bacteria is... Where do I put the 45,000? Oh, that's right, because when I'm doubling, 10,000 became 20,000, 45,000, okay, whatever, it's something different. I don't know. Now, if you want to, you could figure out what the ratio is. You could be like, oh, hey, it was 10, now it's 45. Isn't that going to be 45 over 10, which is, what, 9 halves? You could figure out the ratio if you want. They could have even told you something like, hey, When is it 450% what it was?
What's 10 by 10?
Or 4.5 times bigger? Either way. But we still have that e to the kt. And that's going to be my e to the kt. So isn't my time just going to equal ln of 9/2? All over 0.02? Not days, sorry, hours. Wait a minute, for exponential growth and decay, can't you always figure out how long it's going to take to be something by knowing the ratio and the comparison? Because I'm always going to have ln of the ratio over the k.
Is that like a thing?
For exponential growth and decay, yeah. Relationship between t and k and relationship between k and t. So doubling in half-life, I can use 2 because ln of 2 is my doubling, or negative ln of 1/2 is ln of 2, which is my half-lifing. But I could also talk about like 4.5 times ln of 4.5 over. Anyway, kind of snazzy in that chemistry formula of ln of 2 for doubling in half-life, I can make it ln of any ratio. It doesn't have to be 2. That was just like, oh, doubling in half-life is special. So let's use that one. So what if the problem changes a little bit? I do not have
letter E.
Okay. This one, it's exponential growth again, doubling, that's getting bigger, right? So y is equal to, sorry, y prime is equal to ky. What's my initial condition? We don't know. We don't have a clue. I mean, we have a clue, but we don't have a point, right?
No.
So this is a weird initial value because they didn't give me a point. Instead, they decided to give me a random clue that I don't really want. I'd much rather have an initial condition.
Is this like something that's dependent on the previous one?
No. This is A. We're starting A. So eagle eye doubles every 20 minutes. That's all I know. So I don't have my point, which is super annoying. When I go to try to do my formula for y of t, I'm going to be like, okay, sweet. So I know y of t is equal to some initial that I don't actually know. E to the k I don't really know. And t. But wait a minute.
You know T.
What? Well, I know a t. What do I know is going on for 20 minutes?
Double.
The ratio is 2. I didn't need to know where it started to be able to set the ratio equal to 2. I'm like, I don't know, but whatever that guy was, divide it, and it's 2.
Wait, so what happened to the C? Oh, it's the ratio.
I divided. So I was able to make the ratio equal to 2. And then I can say ln of 2. Remember that whole relationship that kids probably memorized. Doubling. Okay, so k, I know what k is. But what am I having some issues with? What do I still not know? Now, would it change if I told you I had summarized like a whole paragraph of information and I didn't write down the following?
Yeah, it's just one.
Yeah. So there was a little bit extra information I didn't realize until later. I'm like, They actually did give it to me, just in a very unconventional way. So technically, what was the clue that I just didn't write down? A single E. coli, aka what was the amount at 0? Just one. But it takes them 20 minutes to double. And then those 2 will double in 20 more minutes. And then those 4 will double in.
So this is like the actual formula for things that double.
Doubling in half-life.
Wow.
And this is the special differential equation. Oh, that's not fair. The direct proportionality between rate and amount that is kind of working behind the scenes. So we technically have y of t is equal to 1 e to the ln of 2. You can see the calculus behind the scenes. Well, and the math of just solving for k, etc. Ooh, how many cells are present after 2 hours?
You plug in 2.
No, don't plug in 2. That's 20 minutes. We're doing everything by minute.
180.
Oh,
Sorry, 120.
120. Woo! All right. We have our E, we have our ln of 2
Big
all over
brain.
20 minutes, and we're multiplying by 120 minutes. Wait a minute, isn't this something I should be able to do? Look at this, isn't 20 over 120 just 6? And can't I say e to the ln of 2 all times 6, wait, times 6, wouldn't that be like times 6? And wouldn't that be like 2 to the 6? So wouldn't I?
4, 4, 8,
8 and 8 is 64. Just think 8 and 8.
8, 8, 8.
Oh.
2 cubed and 2 cubed.
Got it.
That's how I do 3 to the 4th, because it's 3 squared, 9 and 9 is 81. Fun mental math. Whoa! How long does it take for the number of cells to reach 1 million?
What did you just say?
Wait a minute, how are we supposed to, how do we do this?
I feel her spirit in this room.
So funny.
Another Ellen.
Can you
Fine, honestly.
Isn't a power to a power multiplication?
Yeah.
So can't I take that away? And then can't I do 2 to the 1 over 20t?
Oh.
Because it's multiply, power to a power, you multiply.
divide by 2 to the 120th?
Yep, 1 million divided by 2 to the 120th equals t. I wonder how long it would take for my single equalize to become 1 million. I'm gonna go plug it in my calculator as you guys get out of here. Later, Dana.
Let's see, do I get my coffee or do I just cut myself?
How are you feeling? Shaky yet?
No. Oh, it's going to show up now.
Okay, I have something to do.
Alright.
What is her name?
It would take 965,000 minutes, which would be 16,000 hours, which would be 670 days, which would be about 2 years.
It's not Natasha.
And don't forget sweatshirt, t-shirt, and
Oh,
her name is